This is a nice hype song that I have for when we go live, and we are. Yay! Hello, beautiful humans. Welcome to part 2 of Teach Jenn Snowflake. Teach many of us Snowflake with Anthony. Anthony, who are you?
Hello, Jen, and hello, everyone again. So Anthony Schneider is my name. I am a senior solutions engineer at Snowflake. So as mentioned previously, I joined Snowflake from a customer of Snowflake. I used to work at Nectar, the loyalty program in the UK. So, you swipe your card and you get points for every transaction. So we did a big on-prem to the cloud and Snowflake movement as part of that remit. So that's sort of my background is data architect. And yeah, now I work with customers on Snowflake, implementing Snowflake best practices and showing them how it works, similar to what I'm doing with yourselves today.
Yay! All right. Well, I'm looking forward to seeing a lot more of. Last time we talked a lot about theory, and today we're talking like actually being able to see it and like the workflow. And hi, Anthony. Welcome to the stream. Okay. And if you're ready,
So we got two Anthonys, right?
Yes, we have
Yeah.
other I'm going to call the other Anthony in the chat. I'll call him AJC Web Dev because that's what I call him when I'm talking to him about his Twitter. Like if I'm like, yeah, Anthony Campolo, people are like, who? I'm like AJC Web Dev, and they're like, oh yeah, because people know others' Twitter handles as identification. So
yeah, I'll have to get a Twitter handle. Good idea.
But
Cool.
AJC Web Dev, is there anything you're curious about learning today? Or anybody else that is joining us among the platforms? Okay, just soak it all in. I mean, that's fair. That is fair. It is a lot to learn with all the data infrastructure, and it was cool doing it a month ago now. About a month ago.
Yeah.
So it'll be a good refresher.
Yeah.
Where would you like to start?
I don't know. We can probably jump in. I guess at a high level, similar to what we talked about last week. I think, and to your point there is a lot to learn, and I try to tell people not to get too overwhelmed and focus on a particular part of it if you are new into the journey of this as your career. As I said before, I think being in a support role and supporting things that other people built is a great way to learn. But also what I'm going to show you today is based on some publicly available data. So I also mentioned that last time is that, you could probably try and spin up your own Snowflake account and replicate what I've done. I think that's a really good way to learn and start to get that feel from the full end-to-end process of how you would become, be it a data engineer, which is probably the primary focus of today, which is getting data from source, bringing it through a data lake, data warehouse, and then visualizing it on the other side. I think that's probably a good journey to start on if anyone's interested.
I feel like that's something that I'm going to end up doing on stream now is just trying to replicate today. It's going to be a little scary.
Yeah, okay. I'll send you the quick starts. They've got really good step-by-step guide. I think that's probably the best way. But yeah, I think then if you want to try and replicate mine and see if you come up with the same answers, that's probably a good challenge to set for yourself.
All right. And for anybody that missed the last stream we did together, I'll post it in the chat so people can check out the blog, and it also gives a link to the YouTube video. So that is going as well.
Cool. What I might do is I might just share a bit of a reference architecture or high level design. If you can share my screen.
Perfect.
We got that?
Yep.
So hopefully this isn't too overwhelming because our whole story, particularly at Snowflake, is about simplicity. But this is typically what I would share with customers after having a couple of conversations with them. We'd talk about their use cases. For anyone that's not familiar with the term of use case, it's a problem that you're trying to solve, a case that you're trying to solve with the platform. So I might walk into a customer. In this example, let's say our fictional customer, which is a real company, right, is Amazon Marketplace that sells products. And we'll say that, Jeff has said, I want to understand the sorts of people that are making reviews on our products. And perhaps I want to set up a data pipeline to bring all that review data in and try and find the number of reviews that are being made every day. Perhaps I want to look at reviews that are particularly negative, that have a negative sentiment, and I want to be able to contact those customers to sort of offer them free credits. That would be an example of a use case that a customer brings to me. And then what I would do is I'd build up a high level architecture as to how you would actually build the solution to solve that particular problem that Jeff gave us there. So a few of the elements here, and just to link it back to a few of the discussion points we had last week, typically you have data, it says on-premise there, but that can be in the cloud as well. You have data sitting in data sources. So if we think about Amazon and you go in and you write a review, as soon as you write that review, it's stored in the operational system that maintains that review. So that may be a source database, there may be a source application. In this example, let's say I'm bringing together both the reviews that people write on Amazon with the customer data that sits in Salesforce in a CRM. So what typically a Snowflake customer has to do is it has to connect into those sources and bring that data into the data lake, or Snowflake in this example. And we have a number of connectors on the cloud that you can use and you can click on to bring that in. The data for today's demo is largely going to be some data that a university in America has made available, which is the real review data from Amazon Marketplace. But I'm going to be using our native Amazon S3 connector because that's all stored in CSV files sitting on blob storage in Amazon. So that's the connector that I'll show. The other thing, and I know, Jen, you've had a bit of experience around streaming data, is whilst I won't be showing how to set that up today, for real-time use cases, let's pretend Jeff's requirement is as soon as someone writes a bad review, I want to quickly ping them a message and say, sorry, you had a bad experience. That's where you might leverage something like Snowpipe streaming that actually streams that data directly through to Snowflake, measures the sentiment, and then orchestrates something else that pings the customer. So these are the real-time use cases that people can do in Snowflake as well. A couple of the other things that I'll show is doing some transformations on that data, obviously, because the data that you get out of the, let's say the review data is in JSON, which is a semi-structured format. What we want to do is apply some cleansing and transform that data so that it can be visualized on the other side. And that's a key component to data warehousing or building data lake houses, is that you need to bring that data through various layers. The other key element that I mentioned before was around the pattern of ELT. So you're extracting, you're loading, and then you're transforming. Another key terminology that anyone starting out will hear is something called medallion architecture. That's just a new name for effectively that ELT pattern that I've talked about. And it's about bringing the data in its rawest form. If you can see there, I've got the raw layer in Snowflake. So it's keeping it in its rawest form, doing some cleansing, which I'll show you, and then moving it into a curated layer, which is that gold layer. The curated data is where it's all very nice and clean. It sits in a very subset set of tables, and it allows people that are using the analysis tools like Tableau or Power BI to be able to consume that data really easily. And that's pretty much it. Any questions on that?
Question. Yes. Yeah. It all made sense until we got to the 3 layers with the raw layer, the cleanse layer, and the curated layer. What does RL made sense to me that it's like, oh, it's probably like raw layer. But then it's IL and PL.
Yeah, so that's really good. I got to change this slide. What you'll find is a really good point, because what happens in this industry, there's no set of conformed naming conventions for those layers. And that's why I guess medallion and bronze, silver, gold has probably taken precedence, because it's so ambiguous. It can be used for different ways. But effectively, the raw cleanse curated is trying to tell you what we're doing in each of those layers. So the raw layer data is at its rawest. The silver layer there, the cleansed layer, we're cleaning it up. So we're getting rid of erroneous records that the source system might have accidentally put in there. And the curated layer is, bring it into what would be referred to as a star schema that makes it easy for a reporting tool. So the RLILPL, which I'll probably take out of this slide in the future because I've had that before, stands for raw layer. The IL stands for integrated layer, integration layer. Why it's called integration is that you're integrating data sources together primarily. So if you think about a big customer, they have 5 CRMs. So Anthony is a customer of Amazon Marketplace, is a customer of AWS, is a customer of a bookstore on the marketplace. There might actually be 3 records for Anthony. So what a person in Snowflake that wants to get a single source of truth for Anthony, so I get a single record for Anthony, needs to do is he needs to, or she needs to, integrate those 3 records into one. So you're integrating data together, but you're also integrating the business logic that brings that all into one. So that's where the word integration comes from. But granted, I think that just confuses people, so it might be better to remove that. And PL is a presentation layer because, as I mentioned before, you're kind of presenting that to the business. So that's kind of another nomenclature. And that's probably what most people get really confused about. It's like, what should I name these things? And the difficult thing is that there is no globally. I'll walk into one company and walk into the other, and they'll have completely different naming conventions for those various layers. But at the end of the day, anyone who's doing ELT, and particularly Snowflake customers or anyone using cloud data warehousing or data lake, will have a version of that. Because it's just a well-defined pattern that we recommend these days.
Awesome. Then that makes sense. Thank you.
Okay, cool. So yeah, if you don't have any other questions on that, I might just jump into the platform.
That'd be cool. Thank you.
Okay. So anyone that spins up a trial, or if you're an existing customer hosted these days, you can connect external tools into Snowflake. Like some people use a tool called dbeaver. I think that's database. It's like a beaver, but you can. I don't know the naming convention, but effectively you need to write SQL against Snowflake. We give you a full front end to do that, but you can use third-party tools to do that as well. So I'm going to log in as my fictional data engineer called Boris. And this is just multi-factor authentication, which again, with everything that's going on in the world these days, we now kind of have ways that you enforce multi-factor authentication to make sure that you've got that added level of security when logging in. And this is the Snowflake UI. So this is what a data engineer would work in day out to build those data pipelines to bring data in. The part I probably won't show you, like if I'm starting out with a brand new account, there'll be nothing in here. I'd probably click on this create button, and I'd probably want to add data in to my Snowflake account so I can start to do some of the stuff I talked about. You'll see a number of sources of data within here that you can use to bring into Snowflake. So as I said, I wanted to connect to an S3 bucket in Amazon where there's a whole bunch of CSV data sitting in there. What I would do is I'd click that AWS S3 link, and I'd put Amazon has these S3 URLs. So once I know the URL of the S3 bucket that contains that data, I'd put that in there. I'd give it a name. For anyone wondering what the word stage there means, that's a bit historical, because historically you used to stage data in a bucket, bring it into Snowflake, and then get rid of it. But there are, that's where that name comes from. So it's effectively allowing Snowflake authorized access into a bucket in this example. Same thing if we, built on our MySQL connector here, we'd set up a connection to MySQL and we'd have authorized access into that MySQL database so that we could bring data out of MySQL and bring it into Snowflake.
And if I'm looking at this right, this means that we could bring data cross cloud.
Correct. Yeah. So
that's pretty cool.
It's a really good point, actually, because Snowflake obviously sits above the clouds, and we have native integrations with Microsoft Azure, Google Cloud, and Amazon. Just because this Snowflake account's hosted on AWS doesn't limit me to being able to bring data in from Google Cloud Storage, as an example.
Very cool.
Cool. So I'm going to click on my projects button here. So we've got the concept of organizing things into folders. I'll just go into my Amazon demo. and go to my load historical reviews. So this is a worksheet. This is where you write all your SQL. So as I mentioned previously, actually all practitioners with Snowflake do need to know SQL. It's a bit unrealistic to do anything in the platform without knowing SQL. We do support Python as well in a worksheet here. So if we go, I won't show you that yet, but you can write in Python, SQL, Scala, or Java in Snowflake. So what we want to do first off is create a database. So I'm going to create a database called Amazon. A database has a hierarchical level. You've got your database, your schema, and then your table or tables and views. So we create a schema similar to what we mentioned before. I'm going to call it raw rather than RL, but that's kind of where the naming conventions are important, because you kind of want to keep those consistent throughout your platform so that people know when they're in that schema, they're looking at the raw data. Now I'm going to create a table. Again, a lot of this can be automated, but I'm showing you the manual way of doing this. I'm going to create a table that loads the data that comes out of the API that of the Amazon reviews data, because it's in a JSON format. JSON's the most popular format for data coming out of web services these days. And the good thing about that is that Snowflake has this variant data type. So anyone that's familiar with databases, you'll create multiple columns and you'll determine the type of data that's in that column. With a JSON, we just kind of ram it all into this variant data type, which makes it a bit easy. That's because it's semi-structured, right? It will change a little bit depending on the record. So I'll create that table. Now what this does is it lists all the files that are sitting in that stage, which you didn't see me create, but I created it to an S3 bucket. But what that list command is doing is this Snowflake account is going to that S3 bucket and it's saying, list me out all the files that sit within that reviews folder within S3. So if anyone's looked at S3, you can see that's a real bucket that sits in S3. And it's showing me the size of every single one of the, I said CSV files before, I meant to say JSON files. So there's a whole bunch of JSON, gzip to JSON files sitting in an S3 bucket. I can actually start to look at those. Do you have a
Quick question.
Yeah.
Was there anything that needed to be prepped on the S3 side before you imported the data?
So I haven't imported the data yet. So that's the main thing to mention. I've just reached into the S3 bucket and had a look at what's in
Okay.
it. Now, in terms of, was anything done to these files? As I mentioned before, these were made available by the, I have to get the name so I can reference them properly. We'll put that in afterwards, the university that made this data available. But I can show you what that data looks like. I'm going to do a quick, this select from that Amazon stage and just grab the first 100 records from it. So this is the raw JSON data here. So there's nothing really has been done to that. That's directly what comes out of the API, which is a key value pair. Yeah. So it's got an ASIN, which is, I think, the product identifier in Amazon, the rating someone gave it, and the text associated with that rating of the product and the timestamp it was made. So the good thing is, like, without even importing that data into Snowflake, I can start to look at it. And that's a good use case for data engineers, because you may have, let's say, a petabyte of data sitting in S3 that all your source systems have just been pumping data out into blob storage, as an example. And this is a good way to just explore it to make sure it's the right data. Make sure that is what I need before I import that to Snowflake. So then the next question some people say is, well, you've queried it already there. Why would I even need to bring it into another layer? Why bring it into a table? This statement here that's bringing it into a table, it's going to bring all these records and all those JSON files into a table. It's doing some really cool, important stuff behind the scenes. It's actually doing some parameterization, capturing a lot of metadata. And why that's very important is that when you then go to query that data and cleanse it and bring it together, like we're going to do in the further steps, you get these huge performance benefits. So as an example, if I say, show me all the products that have an image versus ones that don't have an image, because we've loaded that into Snowflake, Snowflake's smart enough to know when there's actual data within a particular column or not, and it can ignore the ones where there's not. What that means is we don't do these massive scans of S3, and it's a lot more performant, which in our world, more performance means less query time, which means less cost, right? because every time you run a query in Snowflake, the quicker it runs, the less amount of money you're paying to Snowflake, because compute's only running while you're querying the data. So what I'm going to do is I'm going to run that copy statement. So that's lifting the file out of S3, which is outside of Snowflake. It could be Google Cloud Storage, it could be Azure Blob. In this case, it's Azure Amazon S3. What it's done in that instance that I clicked play there, have you ever interacted with Amazon, Jen, and spun up an EC2 instance or anything like that?
Yes, and also a question from AJC Web Dev of, does Snowflake support GraphQL too?
No, we have some partners on our marketplace that deploy within the Snowflake platform to support GraphQL. I think it's Neo4j and I've forgotten the other one. We are looking at maybe supporting the GraphQL API, but I think that's more of a roadmap item. So not to this day.
Thank you.
So that, yeah, so in the reason I asked about working with Amazon and spinning up EC2s, I've done that in my past life as well. It's actually quite complex, right? You have to go in, spin it up, you need IAM permissions, you need to figure out how to shut it down. Maybe you need to build scripts to automatically shut it down, and all that, fun and games. When I clicked play there, Snowflake did all that work behind the scenes for you automatically. So what it did was you can see up here, I've got a compute cluster, or this is what we refer to as a virtual warehouse called our load warehouse. What that did, at the moment I pressed play, it went behind the scenes to Amazon. It grabbed an EC2 instance. It dedicated that EC2 instance to my account. It deployed all the Snowflake software on that EC2 instance, and then it ran the code. And then after I finished, now that it's not green, it's shut down again. So I'm not paying for it while I'm not doing anything. So all that's kind of happened behind the scene. And that's kind of the value add that you get from Snowflake, is that we're doing all the engineering of the AWS services behind the scenes.
AJC Web Dev said EC2 is a nightmare.
Yeah, I mean, Amazon, AWS in general is amazing, right? But it is a nightmare. And that's why cloud engineering as a job is also probably a lucrative one, because it is very complex. Like, it is a very important skill set, but a very hard skill set to learn everything that exists in AWS.
Very true.
Trying to script things and automate things there is really hard, which is where the value, I think, of SaaS products like Snowflake comes in, because we're abstracting that complexity that you have. We're trying to manage AWS and the other cloud providers. The other big thing that kind of blows a lot of customers away, those coming from on-premise, is I ran that on an extra small, which is a tiny EC2 instance, and I loaded, how many did we load? We loaded 1.7 million rows in 10 seconds or whatever it was. But now I want to load 20 years of historical data in. So I've got 20 years worth of review data. So I think it's about a terabyte, or it's a huge amount of data. In the on-prem world, I couldn't just call up my hardware team and say, hey, can you stick 20 blades into the data center? That's a 6-month job, right? To get more compute thrown at your platform. And even in cloud customers, the remit of resizing compute often falls within IT departments. I have to log a ticket, I have to get IT, and they'll say, why do you want more compute? And then you're still looking at like weeks of effort just to get some more compute. The difference that we're providing is that we're giving the end users the ability to control that. So Boris has the permissions. He doesn't have to, but he does in this case have the permissions to resize compute. So what we can do is we can look at our compute cluster here and say, you know what, I want to throw double the amount of compute at that. Or medium, I want to throw 4 times the amount of compute. Or double again, 8 times the amount of compute, 16 times, 32 times. So Boris can go in and say, I'm going to load a big historical load now. I'm going to throw 32 times the amount of compute at this. So he just clicks that button. I'm going to load the entire set, not just 2009. Click play. In a mere, what was that, half a second there, it's gone away and it's thrown 32 times the amount of compute at Snowflake. So we're talking about huge amounts of CPU now being thrown at this query to actually bring that data in from S3 and then bring it into Snowflake. So that's just something that is often an IT team doesn't necessarily need to get involved. You can put budget controls on it and things like that, but it's because there's no coding or there's very little coding to do to initiate that. It kind of empowers, let's say, an analyst or a data engineer or a data scientist to control the compute themselves without needing to get sort of a central IT team involved.
Makes sense.
So that's cruising through, done 270 million rows. I think, I forget how many are there in here. I think there's about 600 million reviews or something like that. So we'll just give that a minute.
I've now logged into Snowflake on my side, and I'm like looking at it to be like, ooh, where can you add things from? All the different things you can do.
That's good. Yeah, and that's an important point that some people say we're expensive. We're not. That's just an attack that some of our competitors hit at us. I have some customers that literally they bring in, 100 rows of data and then they show it in Tableau and then they shut it down immediately after. And if you're only running workloads for 10 minutes a week, your Snowflake bill is going to be about, 50 cents a week. So it really caters not just for the massive, large organizations, which obviously run a lot more things, but the small organizations, because of that startup spin down nature of Snowflake, means that it's very, it can be a very good cost profile for customers as well, even with small amounts of data. So that loaded our 650 million rows, still in a minute of data. And now Boris can say, oh, I don't need the 2x large anymore. I can spin that back down to a small. Obviously, you can automate that as well to immediately size down after the load. So just to be clear where we are in the stage, we're still at the raw stage. I haven't really cleansed any of this data yet. I've just brought it in to Snowflake so that I get some of those performance benefits out of it when I start to query it. So we've got the raw JSON data sitting in Snowflake, similar to what I showed you before. So we've got a product ID, we've got the text within there. And this is another thing that a lot of people who have worked with JSON in other platforms really liked about us, particularly 5 years ago when no one else was doing it, was the ability to query JSON data was always very difficult and you needed to know Python. This is just SQL here, and the ability to kind of extract data out of a JSON is very easy. You just give it the title, which is the JSON field that I put it in, and I extract the key out, right? So I'm going to get the title of the review, and I'm going to get the text of the review out, and just so select those two fields from the table, limiting it to 100 records. And you can see how JSON is inherently semi-structured, but I'm bringing a structure into the data now without necessarily having to manipulate it up front. So that can be handy. You can put a view on top of semi-structured data so that someone can then start to access it in a structured way, because structured data is a lot easier for people to work with as opposed to that raw JSON format that I showed you before. So that's going to JSON. So as you can imagine, I'm starting to do some of the transform work here in a development fashion. We can actually build pipelines to actually bring that JSON data out into a structure as well. So this is what that might look like. We can flatten out the images because in a JSON document, you may have one or more images within there. So what this is doing is it's doing a flattening, and it's saying for that image record, give me every image that's attached to that review. So you can kind of see here we've got this review titled "One Tire Flat by AM After Installation." Probably not a very happy review. They've actually put a picture in it. I can click the picture. You can say he wasn't a very happy customer. So I guess the tire was flat. So yeah, what that's doing is it's flattening out. This is the second image. Because there's multiple images attached to that JSON document there, it's flattened them out so that we can start to easily access those. So moving on to kind of building a data pipeline. So I've got all my raw data in. Now Boris is going to have some sort of requirements around needing to flatten that data out or needing to cleanse it of some. I mentioned before, a common thing we see is that the source systems aren't particularly clean, and he needs to do some cleaning of that data. in this example, let's say the requirement of that data from raw is that there's some reviews with a timestamp of the year 1900 in there, and they're obvious erroneous records. So this would be an example in that cleansed layer. Just to confuse you, I've called it persistent staging area. Again, naming conventions are all a little bit up in the air, but what we're saying is take the data from my raw table. See, that's the raw table where I loaded that data in. And it's saying where the review timestamp is the year 1900. I want to cleanse that data out. I don't want that available in that next layer because it's not real data. So this would be an example of a transformation job that actually creates what we refer to as a dynamic table. It takes the data on a lag. So we could do it every hour. If it was real time, we could do, or near real time, we could kind of do every 1 minute. And it's going to automatically go through, and it's going to, every time data is streaming in, it's going to bring new records in and cleanse any of the records from the year 1900 that appear in there so that they don't appear in that next layer. Does that make sense?
It does. And quick question, was it University of California that
made this data available? I'll have to check.
Yeah.
I've forgotten.
Okay.
But I'll definitely get that reference in there.
I'm looking at it at the same time because this is really fascinating, being able to see how it can be manipulated, but also what you can see without even having to make changes. Just being able to know what to call to see. This has been pretty cool.
Cool. So we can see now, querying that new cleanse table, there's no records in here from 1900, and it's still kept the raw structure. I won't go through each of the other transformations in here, but this would be an example of a transformation into that integration layer. What I'm doing is I'm extracting all the JSON data out to bring it into columns, which is what a lot of people do within that layer, because we want to get it into a more structured format. And then finally, in the presentation layer, for anyone that's, what you probably want to read a bit about in the presentation layer is Kimball methodology or data vault methodology. And what that's about is it's moving things into star schemas where you have the fact, which is the review itself, and then in the surrounding dimensions, we call them, you might have the customer record and you may have the product record. So that's what a star schema is, and that's what this part of the transformation would be doing within that presentation layer. It's actually assigning some of the surrogate keys, we refer to them, bringing it into that conformed layer and joining it to the other tables. So that's kind of like high level data pipelines. I'll just show you.
For this one, I'm just curious, because if I try to go do this by myself, how did you decide what to transform in it and cleanse from it? Like, is there like a default list people go through and are like, this is what I should cleanse out of it or transform in it?
No, that's the hardest part, because if you don't know the source data, what do you, like, I've built this off that source data that I don't particularly know well. What I did see in there when I built this demo first off, and you'll see it later, I'm going to do the analysis of how many reviews were made day by day. I saw that my chart went all the way from 1900 to 2022, I think it was. I thought 1900, I don't think Amazon was around then. I'm going to have to actually build a cleansing job to cleanse that data out, because clearly there's something wrong with that. And that was how I decided to put that rule in to cleanse the 1900. There's probably 100 other rules that I would want to do to cleanse this. So there's two things. There's the cleansing when the data is erroneous, but there's also the business requirements. So if the business says, I need the gender field from customer, well, then obviously you're going to do a transformation job that brings in the gender field. And in the same way, again, knowing your source system, one source system might say gender is female, male, and other genders, whereas another system might be F, M, X, whatever it is. So part of the transformation logic then would be to bring that into a conformed set, because you can't have, all these different types of nomenclature in the final layer.
AJC Web Dev says that's why they pay you the big bucks.
Exactly. And that's why you can teach that, because there are things, to your point, that you'll learn. I often see these problems in source systems, like what I've said about there. I often see, different attributes defined differently. But a large part of it is knowing your business and knowing the various source systems and how they call things. And some of the worst ones are the where they don't even give it a proper name. Like, you may have a customer field, a customer table somewhere, and it says GPL SI. And you're like, what is a GPL SI? And that's the really tricky part, because I have to try to make sense. Is that data I need? Do I need to bring that through to the presentation there? Or is that just some stupid internal identifier that's irrelevant? It's a really hard part of the job.
Something that comes to mind when you were talking earlier about to set it up with streaming is something that I believe would go through transformation. So that way would be like, let's say those 1-star reviews that would go through a transformation. So that way it can be presentable,
Yep.
gold. Okay. And then that
Oh,
gets sent to a streaming service to be able to notify them.
yeah, good point. So I
Okay.
talked about streaming on the ingestion. You'll have streaming on the way out potentially as well. So
Okay.
let's say the review data is coming through an API that's hitting Kafka, and it's going in there just to capture all that data in real time and make certain decisions. But let's say the sentiment decisions, let's say it's not possible to do that over on that side of the fence. So it's going to stream through to Snowflake in that example. I'll make my sentiment decisions about all the 1-star reviews, and then I'm going to push it back out into a streaming platform so that it can make the appropriate calls to the various applications on the other side. So you could have, a lot of people refer that as reverse ETL. It should be ELT,
Oh,
but ETL is generic. So reverse ETL that we've been talking about, or ELT, is bringing it in, and then reverse ETL is pushing it back out to those systems so that they can make decisions based on that data. We're
interesting.
seeing a lot more of that, particularly in advertising and media, as you can imagine. So, we want to see all customers that have watched a particular show on Netflix, but also done these other actions, and all of that analytics to make that decision about, okay, you watched that show, you did that, and that. As soon as that gets triggered, then fire that off so that the application can send you an advertisement or do whatever they do in their advertising world. So that's a really common story for that
Interesting.
industry.
Thank you.
Yeah, no worries. And I mean, the main benefit about doing that in Snowflake, as you can kind of see here, is if you brought all your data into Snowflake, there's really no question you can't ask of it. Whereas a lot of the other systems that, don't get me wrong, can do those kind of use cases. As you start to join more and more data sets in, and that question about have they met this criteria becomes more and more complex, and you might be joining 50 different sets of data. That's really where our power is lent to, because we can do that extremely performant and extremely fast.
Very
Um,
cool.
So just on the last slide, so I'll quickly show what we've built previously. So I've got all those tables that I've built. Just going to click on one of those tables, which is my main review table in the gold layer. I'll just refer to the medallion architecture. I'm just going to click on this graph just to kind of show you what has been built. I'm just going to expand it so we can see the lineage here. So lineage is really important in data warehousing, because someone inevitably is going to look at this last table and they're going to say, Anthony, this number looks wrong. What did you do in your transforms? So lineage kind of helps you trace through where the data is coming from. So what this is saying is the gold layer review table there, it's getting data from both that review table. It's actually getting a bit of data from a customer table, a product table, all the way back to the silver layer there, all the way back to the raw layer there, all the way back to my Australian customer source and my US customer source. So this is a full end-to-end pipeline of customer data, product data, and review data, all kind of combined into one. So this is a good representation of that. You can see it's all green. If something happened and someone fed some data through that was erroneous and didn't fit my transformation logic there, we'd get a red, and then it'd allow us to investigate what's actually going wrong.
Are you able to add further lineage through this view, or would you go? I guess what would happen if you click the plus sign, and would it add to the lineage from here? Can you
Uh,
add that logic?
in terms
There's
of, so this lineage is just showing you everything in Snowflake. So it won't capture, in your example, if we sent that 1-star reviews out to Google to do advertising, we wouldn't see that element of it.
Okay.
So yeah, this is really mapping everything that's being done in Snowflake. So I was building everything in SQL before, all my transforms. This is actually mapping that out in just a way that you can see it.
I was just wondering because, like, on review fact, since there is a plus sign on the end, like, oh, does that mean you can add more to that? But no.
No, that's
Okay.
just an expansion. Yeah, so in this demo, I built an aggregate table. So an aggregate table is showing me the daily number of product reviews. In a other part of the demo, I do that. So Snowflake captures everything. So if an analyst came in and built another table on top of my review fact table, I'd be able to expand out and see who's using it. And this is really where the governance folks get excited, because if you've got PII data, right, which has name and email address, and perhaps you let some people in marketing access that data, it's important to kind of see, well, where's that being used? Who's pushing that into a table, so that I can kind of get a feel for where my data is being used and who's using it.
Very cool. Okay.
Cool. So last thing I'll show, I just need to select my warehouse here. I'm just going to keep that at a medium, I think. I think my browser is cutting out the part I want to see. Yeah, where's it gone? There it is. So what I'm
Does
going
it
to
have
do now,
Copilot by default?
everyone's got a Copilot these days. I wish we'd called it Snowpilot or something, because
That would have been
everyone's
fun.
got Copilot. Yeah, so we called it Copilot. But the idea here is, I said everyone needs to know SQL here, is we are moving to a world where, whilst I still think SQL experience, and please no one stop learning SQL, 100%, I think this is a great accelerator for, okay, I kind of know what I want to do, but maybe the AI can help me build that SQL stack. So if I just want to ask it, show me the number of historical reviews day by day. Let's try that. What Snowflake now has, because I've built all that data, is it knows the columns, it knows the multiple tables, it can construct the SQL query for me to answer that question. So if I click run on that, it's going to go away, look at my gold layer, because that's the layer I pointed the AI out there. And it's going to attempt to just show me the number of reviews that were made day by day. If we click on the chart here, you'll see there's no records from 1900. Remember, I cleansed all those out. Back in the early days, I think they were selling books then, so maybe we've got some book sales in there, and we've got, a huge number of reviews over in COVID times, probably. So straight away, you've been able to kind of do some analysis, and then we can actually push this chart into a dashboard, which we can share with people around the business as well. So there are some visualization capabilities in Snowflake as well. But often a lot of people use something like Power BI and Tableau, which is a full encompassing visualization product that has a lot as well.
This is fascinating. I'm also like wondering, can it export to like Grafana or something like that if they wanted visualization that way?
Yeah, I think there are people using that. I think you would still have to, I don't think there's a click a button to do that, but there are ways of orchestrating that movement of data out to third parties. We refer to them as, having a memory blank, external functions, I think we call them. So the ability to like call a third party API and send data to that is something that you can set up as well.
I like it.
Of course, you can download it for Excel. Can't stop people from using Excel. Still the most popular tool. So yeah, I think hopefully that's. Well, I think yeah, this is an example. This might be funny actually. We'll do this. A lot of the AI tools are actually quite difficult to use these days. So our kind of proposition is we're trying to make that very easy. We have this thing called Cortex, which has a whole bunch of AI functions built into it. So remember, I extracted the review text. So let's say I wanted to actually look at the sentiment of that review text. All I have to do is call this Snowflake cortex.sentiment function and pass it in that review text. We're seeing a lot of these use cases in help center, sort of help call center text, or at least the call center translated to text, and then you're able to understand sentiment in real time. So it's really as simple as calling a function and passing it the text. And in this example, I'm just saying, in the last day, rank the sentiment of every single review that is made. And I'm ordering it by one. I'm ordering it by that review text. So what it's going to do is it's going to say the ones with the most least sentiment. So we mark sentiment on -1 to +1. The ones with the minus, this is the most angry review that was made in the last day. So we're doing within the last day, current date -1. Let's see what it is. A waste of money, don't buy it. I would have given them 0 stars if possible. I had this shoe rack for a little over 6 months. 6 months isn't bad. I suppose it's a shoe rack. You expect a shoe rack to last more than 6 months. Yeah, okay. That doesn't look great. So I don't want to get sued. I'm sure the shoe rack company, I'm sure that was an erroneous thing. But yeah, anyway. Yeah, there's a lot of, I reckon it'll be actually what I'll do in my next demo. I want to see how many people write negative versus positive reviews, because I do feel like people do like to complain.
That would be cool to see if a certain product has it that way. But since you're mentioning Cortex, I don't know if this is a good time to show it, but in the dashboard, there is a like AI and ML area that has like create custom LLM. And I'm like, what? That's cool. But you mentioned like Cortex, so that one was pretty cool. But then there's the forecasting, the anomaly detection, and I could see the anomaly detection being used quite often. Have you been seeing that yet?
Yeah, forecasting anomaly is huge, but it's also, I mean, what we're also trying to do is put these kind of capabilities in the hands of, there's going to be the data science community is, they'll be able to build a forecasting model easily, right? They'll spin up their own EC2s, they'll host Jupyter notebooks, they'll go to the Python library, et cetera, et cetera. What we're trying to do with some defined models in Snowflake is also put that in the reach of people that perhaps don't have those skill sets. So we give you a fully a walkthrough wizard where you can just supply the data that I've loaded in previously. And I could build easily, I don't know if I'll do it today, but I could easily build a forecasting model for the number of reviews I expect over the next 6 months using that forecasting wizard there.
Oh,
Just through a step through, it'll say, choose the table you want, choose the time element. So it'll just tell you to choose a couple of fields, and then it'll train a model based on your data. The more data you have, the more accurate the forecast is going to be. But it'll train a model based on that, so that we can start to predict, future numbers of reviews coming through in this example. This one's really cool, though. I haven't actually got a lot of experience with that, but a lot of people, LLMs are exploding, right? We all love OpenAI. But what a lot of people are, they're not able to use a lot of those third-party services, and they want to fine-tune a model based on their own data, because the context of your business is really important. So what we're giving them is an easy interface to use an industry-leading LLM. We just signed a partnership with Anthropic as well. So you've got the good, all the goodness from those LLMs, but you're able to fine-tune that model with your own data, so it's very specific to your business needs. So that's pretty cool as well. Definitely
now
had
I
to play with
definitely.
some of those. I need to have a
I
play
was
as
like,
well.
now I want to go look at them all.
Yeah, Mistral's
Oh,
pretty
very
popular.
cool. Is there anything else that we missed in here that you're like, we should definitely take a look at?
Not really. There's so much in here. I only showed a little bit. There's notebooks experience for data scientists. If you want to use a notebook, and if people are used to working in that Python world and visualize throughout, we've got those capabilities. Streamlit is another massive one that we're seeing a lot of uptake. It's like, if I want to really quickly build a dirty dashboard to share around as a prototype, what that's allowing you to do is, with only a few lines of code, build a visual interactive data application. That one's not working. And share that with the business before I go down the full production route. So it really helps accelerate delivery. And I'd be
That's pretty
remiss at
cool.
not actually mentioning the marketplace. So the marketplace has so, like, let's say in Amazon's example there, he said, I think more people write reviews when it's raining. So I kind of want to see when it's raining or when it's rained in the past and predict how many call center staff I have available. In the old world, you have to find a weather provider, right? And you have to connect to their API and do all that nonsense. In Snowflake, you can jump on this marketplace here and just search for weather. And then you'll have a whole bunch of providers like the Met Office in the UK and AccuWeather that provide data sets. You click on the set, see if it meets your criteria, which will have historical weather patterns for the last 10 years. And then if that loads up, the tribulations of using a US count from Australia, there'll be a get button that appears here. And then it's just as simple as clicking get, and then I've got 10 years of historical weather data in my account ready to use. And anyone that's tried to load 10 years of data through files, everything I showed you today was more traditional, right? Loading through files and things. Being able to just go to a marketplace of available data sets and just get that into your account in seconds is pretty valuable.
Okay. Oh, this is cool. And I know that there was somebody that was building on top of Snowflake that I met at the Data Engineering Bites, which my talk came out this week, which was really cool. So I finally get a look at the talk. But they had the really cute koala. It was a little clipped koala. But unfortunately, I do not remember their name, like what they did.
That was a really good partner of ours called Omnata with the cute koalas. So anyone who wants cute koala, speak to these guys at Omnata. Omnata builds applications on top of Snowflake, and they're largely connector applications. So I showed you some connectors that are native to Snowflake, like OS3 connector. What Omnata is doing really well is on top of us, they're building connectors to other applications to bring data into Snowflake. So let's say Jira. Snowflake, we haven't built a Jira connector. Omnata's built a Jira connector that connect to Jira and bring all your Jira data into Snowflake. So a really good partner, and they've got lots of applications to bring data in.
Oh, that's pretty cool.
Yeah, so it's a good point, actually. The marketplace I showed you getting a data set in, it's actually all sorts of providers in here. There's app providers that have connectors like this. There's AI providers that, let's say I want a chatbot. We'll see if one pops up. Let's say I want to chat with my data. And this is actually a cool use case that I'm seeing lots of customers do is internally, they have all their HR data sitting on Snowflake, let's say. What you can do is you can build a chatbot on top of that data and give it to your internal employees to ask questions. We use it internally, right? So the other day I asked on Slack, how many days of leave do I get a year? I should know that, but I moved from the UK to Australia, so I don't. Rather than searching around our internal directory, I could just ask the chatbot powered by Snowflake, how many days of leave do I get? And it's able to leverage all the internal documents, unstructured data around our internal knowledge base, and actually answer that question for me because we connected it with Slack. So the pipeline in that example was all our internal HR documents flowing into Snowflake. And then the chatbot gets called from Slack. So as soon as I write a message into our internal Slack, calls the API, which hits the Snowflake chatbot, answers the question, and pushes it back out to Slack. I forget what we call our Slack bot, I think we call him, that answered that question for me. So yeah, some cool use cases there. Yeah, it worked really well. I thought it would struggle because I didn't tell it I was in Australia, but it knew I was in Australia, presumably because it has the HR information. Anthony Schneider asked this question. His location is Australia, so I'll give him the Australian information. Very good.
I just looked up, and this is something that I've debated looking into before, is data sets for like diabetics and diabetes. Yeah, search it. It's actually pretty cool. It came up with a few that had information on it, and I thought that was really interesting that it like there's some that are by request or free trial, free to try, but it's paid. And I thought that was really cool on just like coming up with data sets to work with to like just try out Snowflake is really cool.
Yeah. Have a go at the COVID one. Was used a lot in the old, when COVID was a thing. That's a free one, but it's worth mentioning. Yeah, when you see there'll be ones in here that you pay for that you can just pay for it automatically and get that data. And then there's other ones by request, which means you have to chat with the company about getting it. But yeah, no, there's a lot, definitely in the healthcare. You can see all the categories. You see a lot in financial as well. Yeah, there's quite a lot of data sets on there these days, which is good.
This is really cool. Thank you for showing us all of this. I appreciate it.
No problems. I know there's a lot to take in. What I can do, yeah, I'll send you some of those quick starts if you do really want to have a go at sort of doing that end-to-end pipeline. But you can kind of see how quick you could get up, answer an analytical question if you have access to that data, sort of by bringing it through something like Snowflake to get that end result.
I definitely do the quick start guides and where that data came from, because I like the idea of being able to expand on it and see where maybe I can get it to show me the best 5-star reviews or something, or like what product had the most bad reviews. And I think that would be really fun to try to get it to do. But I definitely feel like there's more questions, but it's going to be a lot of just messing around with Snowflake and seeing what I can find out.
Yeah, sure. Try and think of a real use case. I had a real use case for me when I was looking in Melbourne where to live. What I wanted a house with a good radius of pubs nearby. So what I did was I went to the marketplace and got some of the geospatial data that's made available for all nodes of where pubs are. And I could do a proximity radius with all the houses that were advertised for rent and the location of pubs around them. So that was a real use case for me. Admittedly, I'm a Snowflake employee, so I had the platform available to do that for free. But it was kind of really easy to build that, which I thought was kind of cool. And I found a good pub in Pran, if anyone's moving to Melbourne, called the College Lawn. So that's where I went.
That's awesome. And yeah, AJC Web Dev said the same. That's an awesome use case. But
Yeah.
I feel like this makes it make data not as scary, because I feel like people don't think it's always as accessible as it can be to mess around with and try things out.
Yeah, it's definitely it's becoming a lot easier. When I started, I'm getting a bit old now, like over 10 years ago, it really was a bit of a black art, and there weren't actually, data warehousing scared a lot of people. It's become so popular now, and a lot of that abstraction of the hardware layer and the infrastructure is what's made it a lot easier. Because in the old days, a query was running slow. I had to know how data was distributed on the hardware and all this nonsense that you just don't have to worry about these days, which makes you be able to be a bit more focused on your learnings, which is really get good in SQL, get good at understanding the data and what you're trying to do with the data. And that's kind of the majority of the skills that you need to start, getting a foothold in the space.
Very cool. Well, thank you so much for joining us today, Anthony. How do people find out more about Snowflake?
Yeah, so if you're at a company, you may have an account team already working with you, so it's worth reaching out to them. Snowflake.com is where all those guides are. So there's definitely some good materials. The dummies books, we've created some dummies books for each element of Snowflake. So there's data science on Snowflake for dummies, data engineering, data analysis. So definitely worth a read of those. And all the quick starts are available on snowflake.com as well.
Great. Thank you so much.
No worries.
Bye all.
All right. See you later.